This is the proportion statistics problem. I'm not even going to read the problem in its original form because they added so much unnecessary wording and numbers just to make it confusing. The first step I did was simplify the problem by taking out all the bulk. Simplified form, out of a random sample of 100 students, 63 go to the lab. Estimate the true proportion of all students enrolled who go to the lab. Answer as a decimal. Already the problem looks much easier just by taking the bulk out. So a large part of statistics is keeping up with the vocabulary, so it's worth defining and making a distinction between a statistic and a parameter. A statistic makes an estimate based on a sample. So if we read the problem out of a random sample, so that tells you right now we're finding a statistic. Of 100 students, 63 go to the lab. Estimate, another keyword that tells you that you're finding a statistic, because if you are finding the true value, you wouldn't have to estimate since you counted everyone. Anyways, estimate the true proportion. Now the true proportion means we want to know what the real number would be if we could count absolutely every student that's enrolled in this class. So the statistic is an estimate based on the sample. The parameter is the true value that you would find if you actually counted every person in your population. In this case, every student that's enrolled in the class, which is really time consuming. So do keep in mind when you want a proportion is a fraction is a part over a whole. So the part would be the portion of concern, and in this case the 63 students that go to the lab, and the whole would be the entire sample, which in this case is 100. So 63 divided by 100 is 0.63. This is an estimate or statistic because we did not count all the students who are enrolled in statistics. We just took a sample, and that's it.